Right. Oh. So, yeah. Hello. What is the issue here? Mhm. I think we have to do this math again, unfortunately, but if we just plug in the numbers, it shouldn't be that bad. So then, let's say we have collided, right? So exit uv dot y equals 0.2, entry height 0.4, y height equals 0.3, midpoint uv dot y equals, that's where we started, right? And that has to be higher than entry height then, so that's 0.5, right? That's a gorilla. All right, so exit uv equals 0.2, entry height equals 0.4, midpoint uv 0.5, y height 0.3. All right. So this is then minus 0.2 divided by minus 0.1 times 0.1 plus 0.5. That is insanely incorrect. Think? Well, I don't know what we're getting here. Maybe this is correct. Oh, we really have to calculate this again. Fucking hell. Let's use our values this time. Here's 0, here's 7. Here's 7. Then we have a ray that does what? It goes down like that. And then here we have green like that. And now this is a little bit difficult, but let's make it look like that, I guess. So we enter at That's this. We enter at 6. I don't know if you can actually do the math here so it makes sense. We enter at 6. The height at entry is 3. I suppose. I don't know if that's right. I know it is. It's right. And then here, our UV is 4. And here, this is 7. Then we once again plug this stuff in. Exit UV is 4. Entry height is 3. Y height is 7. And midpoint is 6. Wait, what? Yeah, that's the entry. So this is now 1 divided by 4 times 3 plus 6. So if I enter at 6, then it says I'm colliding at 5 point. This makes no sense. Is this wrong? Man, I don't know what's happening. This is gonna be the 4th time I redo this calculation, I guess. But I'm missing the next part. Because the next part is using the ray, the entry point, and adding exit point to it. So it might still be right. This one, for example. So, do we have that for this one, for example? Hello, Weasel. Not huge amounts of progress, but some. This is now 0.2, 0.2 minus 0.5 times 0.7 plus 0.5. And then we get 0.29. Let's see. I'm gonna take all of it there. And let's see. The exit UV is 0.2, but the height is 0.39. The entry point is 0.5 and the entry height is 0.4. That means we cannot get a collision height of 0.29. Because we cannot collide at a point lower than the entry and the height. That makes no sense. Oh, yeah, we're doing some maths still. I think I've been doing I felt like I've had some progress, but as you can see here, you have a little split here where you get 0 here and here it becomes 1 in the opposite direction of where it's supposed to be going, kind of. And that's not good. So I'm kind of revisiting my algorithm formula. But I was quite sure it worked. Um, all right, let's do this as simple as we can, more or less. Let's do let's rename everything so it makes sense. Exit UV versus minus entry height. This is target UV, let's call it that. Midpoint UV is entry UV. Y height is target height. And entry height is entry height. All right. And let's make a positive ray. Give it entry UV equals 0.3. Let's go with 0 to 1. And then we have the entry height. It's going to be lower than that. Let's go with 0.1. And then we have target UV equals 0.5. And the target height equals 0.8. Again, we just replace entry UV goes there. Wait, let's also add the final step because it's important. This midpoint UV, this is entry UV, target UV. There. And entry UV goes there, 0.3, 0.3, 0.3. Well, this isn't quite right. This is entry UV dot y, but the entry UV is simply 0, 0, and 0, 3. That's the entry UV. And the target UV is 0.5, 0.5. Here. The target UV goes there then. There. And there is a full F2 float 2. And the entry UV is that. Entry height 0.1. Target height 0.8. And here we have 0.4 divided by 0.7 times 0.3 plus 0.3. Full value. Times 3. Plus 0.3. And we end up with that. Wait, did I just multiply it by 3? What did I do? Yeah, that's not right. 0.4 divided by 0.7 times 0.3. There. That looks more correct. Plus 0.3. Then we have 0.5 minus that. That's going to be F2 0.5 and 0.2 times this. 0.5 times that. And 0.2 times that. Plus 0.3 equals this, and that is like that. So now we ended up with an x value of 0.236. And here we have 0.394. Oh. So if we then compare this with our values and see if we get anything that sounds even remotely correct, then our entry UV is 0.3. And the target UV is 0.5 and the target height is 0.8. And then what we're getting here is that we are intersecting at x 0.236, and the height there is 0.394. I think that sounds pretty believable. So the question is, what part of this formula is causing that? Do we have to do it again? Like I said, this was a positive ray. Which means we are going like this into the thing, like that. So what happens if we go down? Is that a problem? And also, what happens if the UV starts at 0.5? Does that affect the value somehow? But it shouldn't. It's just because this side here is the one side, I think. Yeah, it is. So over here is Z0 and over here is Z1. So for some reason over here when it's I don't really understand. But something is flipping. That's why I'm thinking it might have something to do with maybe we go over into like negative values or something. Plus this ray is negative. It goes down. But I don't know if that matters or not. Kind of doesn't look like it. Over there we also get it. Here we get it further in though. So it has something to do with the curve in some manner. Here I don't get it at all. Why is there nothing here? No, there it is. It's like super tiny there in the edge over there. But so it is here. Man, I don't get it. Is this shit? So is it that the midpoint? What is the temp point? Let's try breaking here, and then we draw temp point here. Yeah, it's the temp point is doing that, yeah. But it's doing it differently now, I feel. Or maybe it's not. Let's try doing this. Only on that side. So is it possibly just that we are getting a division by 0 here somehow? I mean, it can't be only that, and I don't see how this would give an accurate value either. then here in this variant it can't be 0, more or less. I mean, it can. Is there any smarter way that we can calculate the intersection? What about using the ray direction? Is that possible? But it's also... I also feel like my current calculation actually doesn't work. Because it assumes a straight line. And we don't have a straight line. I'm adjusting this line so that it looks like this, right? Like it's a curved line. So I don't think this formula makes sense. So how can we calculate where the intersection is if we have a curved line? I feel like we'd have to know, we'd have to include the curvature algorithm somehow. I mean, it's not that big of a deal. If you have the entry point and the exit point, then you can just calculate where you intersect that, and then you just add. No, that doesn't make sense. I mean, it has to be added. No, that doesn't work. Because we don't collide there. Like, I could get the height and then adjust the height, but that means that I don't actually collide with that height. But maybe then you could kind of figure out how much it changes and then move forward like that, but there's gotta be a better way to get an intersection that doesn't just involve ray stepping. Hmm. Hello, Peter. Yeah. I don't know if I can do this mathematically. Especially, I don't know if I can do this mathematically. I just know what I want to do. I don't like settling. The only variable, we only have one variable to help us. And that is the intersection difference. Like, that's the only thing that we have. And with that, we have to calculate where we intersect. And it kind of worked when I was just using like straight lines, but we're not anymore. We're using curves. Like this. This volume might look like this. Let's just do that. For example. And then here we have a line that comes like this. And now we have this intersection here in the middle. And we have to use that, this difference, to figure out how we that we collided there. And I'm wondering if we're barking up the wrong tree. Could it be something like that? But how would I get that value? But like what I'm thinking is, generally what I've been doing is, if you have one value for your ray, you have where the ray starts, you have it the rays XYZ. And if you have any other value, you have any ray Y value, then you can use the percentage difference between the original position and the value that you have to calculate the other ray values as well, like the Z and the X, for example. So maybe we can do the same thing here, but instead of calculating the ray position, all we do is we have the entry point of the curve, or we have we have where we are checking currently, right? And then we have the high point of the curve. And if we then just go and we do the same thing, we subtract the Y value from the curve and get its percentage value, then we can reduce the curve formula down by that amount, and then we get this point right here. And I'm not so sure what I think after that, but it seems here like you can get the middle. More or less. You get the middle adjusted by the curvature formula. Holy shit. Holy shit. Is this what I have to do? The question is if it's gonna be any different from this, like the previous algorithm I had. But I want to do what I'm doing now, but it has to be adjusted by the curvature, and I want to avoid divisions. Because right now I'm like reducing heights based on entry height and stuff like that. And because of that, there are too many points where we can get division by 0 or even division by negative, I think. I'm not sure if that's the case, but it might be. And I feel like it's not going very well when that happens. I don't know math. Like, I don't even know what trigonometry is or whatever. I have never looked at Pythagoras, whatever. I'm kind of just trying to figure this out on my own. Fuck those old Greeks, dude. I don't need them. Well, if we start with getting the difference, maybe we can figure something out from there. What kind of values should we use? Let's go with 0 to 31. Or something. 0 to 32 just because. I don't need it. I don't know if I need to count 0 as a value or not. I think it just becomes weird if I do. But I also kind of count 0 as a value at the moment, but I'm not sure I want to do that. Well, no, I don't. I don't count 0 as a value right now. I think. Am I adding +1? No, I'm not adding +1. So we only have... We have 0 to 7. 7 is 1, 0 is 0. Alright. Alright. So let's say we have entry height equals 8. Entry UV equals F2 0. And 16. X target height equals 27. Target UV equals F2. 32, that's 16. And where are we when we are in the middle? Let's in fact start a little bit higher, and then we end in 6, maybe. No, let's end in 8. And then we get target diff equals well, it depends on how we want to do it, I guess. I don't know which way is best. Do you take the ground minus, you know, whatever or whatever? I don't know if it matters. 8 minus 27 equals minus 9. No, minus 19. Minus 19. In fact, I don't even know if we need to do this. We can pretty much just take the target UV's Y, I think. So man, the curvature ruins everything. Yes, you could do. -27 minus 16. That's target height minus entry height. And now we're on the same track as before. The target height minus entry height, and that nets you. This case, 11. What should we expect? Actually, this is not the same. This is not what we need to be using. Plus, that might not have been too far off. We can draw it. Let's see, it's gonna be 0 to 32. That means it has to be 33 in size. Does it have a midpoint? Entry height. Well, 27. Ray goes from 16 to 8. Show me the fucking value. Okay, fair enough. If you do this, what happens? Nothing. Still shows you, yeah. Okay, where's 8? I wish we had a higher value. Let's go with a value like this. So now we enter at 24. Hello, Tulip. My brain hurts. But we're still working on pretty much the same thing. I need to figure out an intersection here. Yeah, I think we're gonna play some Minecraft later tonight, but I might just nothing. But I don't really want to do nothing. There's nothing to do when you're doing nothing. I'm kind of getting kind of bored. I've been watching some Chinese TV, but the latest show is just not great. So, okay. But then what is this? This is still the same value. Before there. Plus, this was wrong. Ooh. Split the voxel using a plane? No. I'm trying to find an intersection. This is just the volume. The volume starts here and it ends there. But the tricky part is that our volume is actually curved because we are using a second degree equation to add the center volume based on how close we are to the center volume. So it's yeah. But that's not even why I'm doing this or redoing this. Reason I'm redoing it is because we get this from my current algorithm. This is supposed to be height, like intersection height, but it's like splitting here from something, and it's inverting, and I don't really know what's going on. So now what are we trying to calculate? $15. We need to subtract the entry height from both of these values. So no, I don't. I don't. We're in uncharted territory. I mean, not really, but there are people who've done similar things, but I guess. But I'm not really following anyone for this. This is just what I want. But it's basically just supposed to look like terrain. Like terrain if you had just meshed it, pretty much. More or less. Just normal terrain. Except here it's based on each voxel's internal volume. That's the goal, at least. So I'm giving each voxel a volume, and then I'm kind of just smoothing the terrain between them. I don't. Right now we don't, but so it's gonna be a little bit weird. But we'll go I have some ideas how to handle it from there. To get the right angles when you have like multiple, like 2 steps, for example, of voxel, and then like 1 step, 1 step, 1 step, 2 steps, you know. But 1 step at a time. Just smoothing the voxels between each other is good enough for the moment. I've already done it relatively easily. Like if you just map the corners, like you don't even need to use the center that I'm using. Like I'm giving every voxel a volume, but you don't need to use the central volume if you don't want to. What you can do is you can just give them a volume, and then you also give them corners. And the corners is based on the 4 surrounding voxels around that corner. And because every voxel around that corner will have that same corner be the same value, you can just draw a line from there to there. You know, it's literally the same idea as just meshing in that case. It's just a way of shaping the voxels after we've found them using raycasting. You can do it any way you want, really. I just kind of imagined I wanted them to have a volume as well. That's why it's extra hard. But yeah, here we should subtract the entry volume from the target volume, but I got kind of caught up thinking about what would happen if I used that same method when we are going from the middle to the exit instead of the entry to the middle, because then, like, here it makes sense because now my entry volume is going to always be lower. Well, that's not true either, but it's usually lower than the middle volume. And that way I can subtract the entry from the middle. But if we start in the middle, then we have a higher volume than at the exit. And if I then subtract that to try to figure out if we collided with anything, well, no, we did collide with something. Well, maybe it's not that big of a deal. I don't know. But it seems to be a big deal, because something is wrong. Anyway, fuck it. Our entry height is 12, so we subtracted 12 from 27. Does this make sense? Because this is a negative percentage here below this. But maybe that's fine. I guess it's fine. We subtract 12 from 8, and then we get -4. And then we do -4 divided by 15 equals that negative. This seems like it's a stupid plan. Maybe I should Google ray tracing intersection math. Could that be a good idea? Maybe. Where they're intersecting. I only have this value. This is where we enter. And we have this value. This is where we exit. Exit. Entry. And what we need is this value right there. And I need the height. But the formula that I have actually gets this just fine. It should. But we're also getting those weirdo artifacts. And I don't know. I don't really know how to solve it. Plus it has some nasty division by zero things going on that I'm not sure how to avoid. As you see here, we have y height. Well, how should I do this? Y height is a float, entry height is a float. It kind of only matters if they're exactly the same, and there's no way that's what's happening. Because if they are the same, then I could just say that it's just this, like that's our height, right? Because they're the same, and there's nothing in between. So if y height equals entry height, then what? Yeah, that's just our height. That's just inter... Else we do that, and we have to do that. And we have to do nothing. So I kind of want to do this just so we can tell if it's doing it. Be red instead. But I don't think this is the issue. Isn't to see there. What is it doing? It's flipping. Why is it flipping? This is what we are working on, right? Let's just make sure that I'm in the right place. Yeah. So the question is, what is happening there? What corresponds to that? If cs test.y equals 1, then we are going to say color equals .4. What do we want to see here? Exit uv.xyz. Maybe. Break. And then I also want... What's our entry point here? Midpoint UV, I think. That to 2. What else can we take? What else can we check? 3 we can check. We can check our Y height. Let's just go in and see. I think it's doing that all on its own somehow. There's nothing that comes before. 4 equals temp point. Five equals intersect. Dot y. That's interesting. So the issue starts with the temp point here. Why though? right. Okay. So we take 8 minus 12. Divided by 27 minus 12. And we get minus 4 divided by 15. This is what we already did. Negative 4 divided by 15 is big messy value. We're gonna keep the big messy value. And then we do times height minus exit UV. What's the idea there? Times the difference? But yeah, this is the percentage of where we are. Shouldn't I just smash this in right away? No. I mean... we have that down there now. Why the difference here? Fine. Times height, that's then 27 minus 8. That's 19 times that equals big ugly value. And then you add the entry UV to that. Then you get 18.9. And this is 18. So like this clearly works, but what are these weird values we're getting? I just don't get it. We have to calculate it again. Let's calculate it again. Except this time we have to change these values so that we intersect like this. Right? So then we do this again. But it like only happens on a very specific place too. So I don't really understand what's going on. So now we have 18. Entry height is 18. Like if I simply have to adjust the algorithm somehow when we have a higher starting point than ending point, fine, whatever. But we gotta figure out how the hell we do that. However, this is now important. Because before it was like that, and now it's like that. So I think it's always in this order. This will be 4 now. It's y height minus height minus UV, yeah. Hello, Lightblade. How's it going? So we do exit UV. That's gonna be 8 minus 18 divided by y height. That's target height 12 minus 18. And see, now we're gonna have a negative divided by a negative. And I wonder if that's what fucks it up. That's a very expensive mount. Chinesium one. What's the worst thing that can happen? That it breaks and your TV falls on the floor and explodes. It'll be fine. I don't even know if the brackets, like the actual mount itself, is really that big of an issue. I mean, maybe. But as long as it's not plastic, I'm more concerned with it falling off the wall than the thing breaking entirely. But I don't know, I've never used them either. Times y height 12 minus exit UV 8 plus entry UV, which is 24. Now, how fucked up is this going to be? 8 minus 18 is minus 10. 12 minus 18 is minus 6. So 10 negative divided by 6 negative is 1 times 4 you can already see it's gonna be something terrible here. 6 and then it gets plus 24. Let's see if it's as simple as flipping it to negative. So plus 24. So obviously that's wrong. But what if we subtract 24 from it? Or what if we... I'm rather thinking... What if we subtract 6 from 24? Then we get 24 minus... That's 17.3. And what is this? 15. That's not right. 18. Did I even do the last step? The last step is important. No, I didn't do that. So this isn't even accurate. Like, this is something else, I think. Let's try this. This is gonna make no sense though. That's gonna be 24 plus that. That's 30. And then we need to divide that by 32. Then we get that. And then we take midpoint, that's the starting point. So we take enter UV plus this times exit UV 16.8 minus F2 0.24 and that is 16 negative 8, no, negative 16. And the other one is just gonna be the same, but positive then, I guess. Good. And then here it's saying that we're intersecting at 15, which isn't true. And we're intersecting at negative 15, which is actually almost true. We're intersecting at 15. So it's kind of getting the value. Holy shit, how do I solve this? It needs to be different. If the entry height is lower than the exit height, then it works. I think. But otherwise it gets flipped. So how do we calculate this then? Do we have to make a new calculation from scratch here? I think it is tea time, break time. Oh, my brain. I think I'm unironically overworking a little bit. I've been thinking about taking the rest of the day off. I just didn't really want to leave it in the middle of this math. But I think we've taken a step forward. I think you can basically have to reverse the algorithm here to some extent, because this does not work. So it might be as simple as this. If we go in here, here we have our intersect, right? So what if we try if entry height is lower than y height, then we can do this, else call equals negative intersect y. Yep, it's still there. It's just different now. It's even worse, actually. So yeah, there are still things with this algorithm that needs to be changed. It's not enough to just do this. Flip it. Because it was close to being correct, but it's not. Plus, the algorithm is incomplete. It needs to have it needs to take into consideration the second degree equation that's added to add the central height. And I'm not sure how to deal with that. Because getting a point on a line is one thing, but then we have to adjust it for something else. I don't know, but it might be doable. It might just be that you have to shift it in a direction based on a percentage value you can get. So it might not be that bad. Because what you can get is, you can get your intersection, right? And then you have to calculate the actual new position from that. And then you can calculate how much you need to shift up your calculated position in the direction based on how much it's going up there. Kind of. Easier said than done, but... yeah, I think we'll stop there for today. I don't know what to I don't know what to write. Let's see. Something like that. But I'm about to have an aneurysm, so we're stopping there. My brain is like got like a little pinch up on my head here. It's weird. So I'm gonna go have a little lie down. And then I'll see. Like, I might play some Minecraft, but I might not. But otherwise I'll be back tomorrow. So I'll see you when I see you. Until then, thanks for hanging. Have a good night. Bye-bye.